Okay. In this problem, we've got a process costing, and it just has conversion. There's no materials in this, and we're using the FIFO method. So they want to know what the conversion costs for drying and package department August 31. So to do that, we need to get the equivalent units, the cost per equivalent unit, and then the cost in the inventory, which is work in process. So we start with our physical flow schedule, the beginning inventory, and that's 100,000 units, which is given there. And then our transferred in is 540,000 units, giving us units to account for of 640,000. We don't have the ending inventory. We'll have to calculate that. But we do know the transferred out to finished goods is 400,000. We do know the units to account for are 640,000. So that means 240,000 physical units are in ending inventory. Okay. Now, with the FIFO method, this top part, the percent complete, is important. We're told that beginning inventory is 60% complete. So 60% of 100,000 is 60,000. And the ending inventory was 30% complete. So 30% of 240,000 is 72,000. Okay. Now, we also need the transferred out gets divided in two parts in FIFO. The first part is the amount to finish what's in beginning inventory. So 100 minus 60 is 40,000 equivalent units to finish what was in beginning inventory. And then the ones that were started and completed will be the 400 transferred out minus the 100 is 300,000, gives us 412,000 total equivalent units. So we're going to do B first. What is the cost per equivalent unit last period and this period? Okay, so last period, we've got the 30,400 divided by the equivalent units of 60,000. Let's see that there. The 60,000 right there. And so that gives us $0, 50.67. I'm going to round to 4 decimal places. So this is last period. And then this period, we use the current cost right here, the 242,000. $242,000 divided by the 412,000 equivalent units this period. And that's going to give us 58.74, again, rounding to 4 decimal places. So that's part B. Part A is going to be then the ending inventory equivalent units of 72,000 times this 0.5874. Gives us an ending inventory of 40,220. Let me do that again. 72,000. Whoops. 72,000 times 0.5874. Okay, something was off. 42,293, rounding up. Okay. And then part C, what are the total costs transferred out for conversion? So we start with the old inventory is 30,400. So that gets transferred out. Plus, right here we have, see, this is ending inventory, so that one's transferred. So we have 340,000 equivalent units transferred out this period, that were done this period. 340,000 times the 5874. So 340,000 0.584 times 107.16 plus the 3,400 is 230,116. So that takes care of that. All right. In this one, we have service department allocation, and it's a little bit funny because there was a mistake. I think this 20 and the 10 got switched. If you add these up across, it's 110%. If you add these up across, it's 90%. So we're going to treat it as if these percents weren't there. They're just numbers like square feet or employees or something like that. Okay. It doesn't really matter on the direct method, part A, but on part B, it does. So, for A, we're going to have P1 and P2. Then we have the S1 is going to be 100,000 times 40 plus 50 is 90. So 40 over 90. That's going to be 44,444. And then S1 here is going to be 100,000 times 50 over 90. That's going to equal 55,055. We'll round up to 6 on that. Then we have to do the S2. That's going to be 80,000 times 55 over 80. And that'll be 55,000. Pretty sure that's right. Let's check. Oops. Yeah, 55,000. And for this one, we will have 80,000 times 25 over 80, which should be 25,000, right? And we just add those two together. 556, 80,556, 99,444. Add those two together, it's 180,000. And that's the service department costs we allocated. Now, in B, we have the step method, and it tells us to allocate S1 first. And so S1 is going to go to S2. It's going to go to P1 and P2. So S2 is going to be 20 over 110, right? Pointed out that this adds up to 110%. And let's do it this way, 100,000. Is going to equal 18,182 if we round it. This one will be 100,000 times 40 over 110. So that should be just double. And that's going to be 36,364 if we round up. And then finally, P2 is 100,000 times 50 over 110. And that's going to be 45,455, again, rounding up. Okay, so now got that. What we do is we add the cost of S2 to S2, the allocated from 1 to 2, and that's going to be 80,000. So that gives us 98,182 that we have to allocate. Now we kind of just ignore that. So this will be 98,182. And now we're back to just like the direct method here, 55 over 80. So it'll be 67,500. And here we got 98,182 times 25 over 1 over 80. Looking up above. And that'll be 30,682. Add those together. 730. 56, 86,037. Add those together. 864, 3,103. And if you add those together, it comes out to $180,001. So $1 rounding error on that. Okay, the third one here in this part, we have a joint process costing. So this one is sales value at split off method. So the sales value at split off, we just add these up and it's 500,000. So for the sugar, we get 200,000 divided by 500,000 times the 600,000. Processing costs would be 240,000. 40% of 600,000 is 240. Then the sugar syrup is going to be 175 divided by 500,000 times 600,000. Will be 210. And finally, the fructose syrup is 125 divided by 500,000 times 600,000. Be 150,000. If we add that all up, that should be 600,000. And so we have the costs allocated there. And our last one of these is a transfer pricing problem. We've got the Colby division, makes a component that can be sold on the outside market, current price of 25, or sold to Bree for use in another product. Colby estimates the component having the following costs based on 50,000 unit capacity. Materials 6, labor 350, and variable overhead 450. So that's the variable cost is 14 on that if we add those up. So A, what transfer price should be used if Colby currently sells 35,000? So Bree needs 10,000 units. We're selling 35. We have a capacity of 50, so we have 15,000 excess capacity. We can meet their 10,000 demand. So the ceiling price is the market price equals 25. The floor equals variable cost equals 14. So as long as the transfer is made, the company as a whole is better off by $11 a unit times 10,000 units would be $110,000 better off. At the floor of 14, then Colby is no better or worse off. But Bree would be $11 better off. At 25, Bree is no better or worse off, but Colby would be $11 per unit better off. So anywhere in between those two is an acceptable price. B is the same because it's 40,000. They need 10 and our capacity is 50. So that's going to put us right at 50 with no wiggle room. But, we're going to say it's the same floor, same ceiling on that because we have the excess capacity. For C, what transfer price should sell at 45,000 units? So now we take into account, so the ceiling is going to be the same, the market. Okay, but the floor this time, we're going to take we've got 45,000 units. Our capacity is 50, so we would have to give up outside sales of 5,000. So it would be 5,000 units times $11 of contribution margin, the 25 minus 14, and then divide that by 10,000 units. That would give you $5.50 plus the 14. Our new floor is 1950. So anywhere between 1950 and 25, both are better off at 25. Bree is no better or worse off at 1950. Colby is no better or worse off. Anywhere in between, both divisions are better off. And regardless of what the price is, the company as a whole is better off by $55,000 this time. And then finally, D, if they are selling 50,000 units, capacity is 50,000 units, they would have to give up all of their contribution margin. So the ceiling is going to be the same as market of 25, but the floor is the same, equals the market of 25. So if this transfer is going to take place, it has to take place at 25 in Part D. All right, let's hope this one works.